Let's look at fractals. In the 2013 Disney film Frozen, Idina Menzel sings a song called Let It Go. I've been hearing it on my kid's iPod recently. It won the Academy Award for Best Original Song. We're going to listen to a certain line from the song. It's at the 2:34 mark of this Disney video on YouTube.
Power flurries through the air into the ground. My soul is spiraling in frozen fractals all around.
My soul is spiraling in frozen fractals all around. What on earth is a fractal? A fractal is a shape that shows detail at every level of magnification, especially a shape that's self-similar. In other words, parts of the shape are similar in shape to the whole. Let's look at some examples of fractals. First one is called a Koch curve, named after the Swedish mathematician Helge von Koch. Here's how we draw a Koch curve. Start with a segment of length 1 and draw an equilateral triangle on the middle third of that line. Equilateral triangle, again, has all sides the same length. So equilateral triangle on the middle third of that line segment. And erase the bottom edge of the triangle and repeat the process on these 4 remaining segments. So this is what we end up with. So here's what I mean by that. Okay, so we're going to draw an equilateral triangle here. And then on this third, we draw an equilateral triangle here. Sorry, kind of sloppy. And then on this third, an equilateral triangle here. And then an equilateral triangle in this middle third. That's pretty good. Okay, and then we erase the bottom of each of these equilateral triangles. And here's what we end up with. So we draw those equilateral triangles, erase the bottom third, we get this. And then we repeat the process over and over and over again. And so notice what we get. This is what we have at the first stage, the second stage, third stage, fourth stage, fifth stage. So again, notice all I'm doing is, making little equilateral triangles in each of these segments and erasing the bottom. And so we just keep on going ad infinitum. And this is what we end up ultimately. It's called the Koch curve. And again, this is a fractal. It shows detail at every level of magnification. If you were to zoom in on this baby, any part of this thing, like this part over here, you'd see detail. But it's also self-similar. Notice this. See this thing here? This is similar in shape. Notice that this is similar in shape to the whole Koch curve. And if you were to look at this little bugger here, this just that little bit is similar in shape to the entire Koch curve. So again, that's a fractal. Self-similar. Parts are similar in shape to the whole. That's what we end up with. Another fractal is the Sierpinski triangle. I'm Polish, so I'm psyched about this Polish mathematician, Wacław Sierpinski, who came up with this. Sierpinski triangle, you start off with an equilateral triangle, and on the middle third, you just basically erase the middle third of the triangle. And then you basically start with the black triangle, erase the middle third, you get this. And then for each of these little black triangles, again, you erase the middle third like this. And then you end up with this, what's over here. And then for each of these little black triangles, you erase the middle third. You get this, and you keep going. You get what's called the Sierpinski triangle or the Sierpinski gasket. This is what it looks like. Sierpinski carpet is the square equivalent of that. You've got a black dot in the middle. And you basically start off with a white square, make a black dot in the very middle, the middle ninth of it, and you keep going. This is the ultimate Sierpinski carpet. Menger sponge is the three-dimensional equivalent of the Sierpinski carpet. You can have a Koch snowflake. Basically just take Koch curves and put them together to form a snowflake. And the most famous fractal is the Mandelbrot set. We have a separate video that deals with that. Okay, but do we see fractals in the real world? You bet. Here's an example of a fractal, Romanesco broccoli. Notice that this part over here is similar in shape to the whole broccoli, to the whole clump of broccoli. Fern, again, notice that just this little shape over here, just this little part, is similar in shape to the whole thing. We also have an agave cactus, similar. Just that middle part is similar in shape to the whole. Nautilus shell, this is another good one. The middle, if you just take a little bit of this, like you just take this part over here, it's basically similar in shape to this whole thing. And it's no coincidence that these are all fractals, because that's the way these animals, that's the way these nautiluses grow. It's just an efficient way to grow. You make each chamber just a little bit larger, and you rotate it slightly. You just keep going, going, going. It's just a natural way to grow. Now let's look at some fractals which don't have the same level of self-similarity, but at least they show detail at every level of magnification. So for instance, lightning. Now if you look at this bit of lightning here, okay, it doesn't look exactly like this whole thing, but it's kind of similar in shape. And again, it does show detail at every level of magnification. Mountain ranges are similar. Check these out. So again, it's hard. So these would also be examples of fractals. You zoom in further and you see more detail. Trees are fractals. Again, same idea here. If you just look at this part over here, in a sense, it looks like the whole tree. Rivers are fractals. Same idea. Check out this chunk over here, and it doesn't look exactly like the whole thing, but it's similar in shape to the whole. Coastlines are similar. Here's another one. This is a branching pattern from electricity. If you send an electrical charge through a certain medium, it will produce a pattern like this. And another example of a fractal. And landscape in general is a fractal. See, again, you can't tell whether this is, it's not clear whether this is 1,000 feet across or whether it's a few inches across. Because as you zoom in, you keep seeing detail. You see detail every level of magnification. And ditto with this one on the left here. Here's another example of a fractal. Here's some more landscape. Ha! It's a computer-generated image of a fractal and not a real landscape. Yeah, I mean, and the fact that you can generate by computer something that looks like a landscape is an indication that landscape really is a fractal. Clouds are fractals. Lungs are fractals. Again, if you just take a little chunk of it, little chunk of lung, now that part is similar in shape to the whole, but really more important, it shows detail at every level of magnification. You just keep zooming in, you see more detail. Ditto with blood vessels. Here are the blood vessels in the retina of the eye. Ditto with neurons. And this is cool. Lichtenberg figures. This is a fractal pattern on skin caused by a lightning strike. We saw earlier that lightning is a fractal. Lightning causes fractals. This is amazing. And of course, ice. Frozen fractals all around.